Welcome back to Chemical Engineering Statistics. In this section, we will discuss about the introduction to full factorial experiments. In doing experiments, there are a lot of methods or experimental design that we can choose. One of the most popular one is factorial design. In doing experiment, we also have a range of variables whose values are varied throughout the experiments. In the topic of factorial design, we call the variables as factors, and the values of each factors called as levels. In a full factorial experiments, that means that each complete replicate of the experiments were conducted at all possible combination of the levels of the factors. The factorial design method can be used to do factor screening and also can be used for model building. However, the model built by the factorial design is limited to the linear models only. Here we can see the example of the full factorial design. In this example, we conduct the evaluation of the effect of reactant concentration and catalyst dose on the conversion of the reaction. So here we have two factors. The first factor is reactant concentration and the second factor is the catalyst dose. We code the reactant concentration as A and catalyst dose as B. For each factor, we have at least two levels. So here, for reactant concentration and catalyst dose, for each of them, we have two levels in this example. The levels of each factors is coded as -1 and +1. -1 implies to the minimum level and +1 implies to the maximum levels. So here if we look at the table, for two factors that have two levels each, we're going to have 4 experiments. The first one is conducted at low level A and low level B. The second one is conducted at high level A and low level B. The third one is conducted at low level A and high level B. And the last one is conducted at high level A and high level B. For each experiment were conducted in triplicates. For each experiment, we also have the notation for experiment run. So here if you can see, for example, B, the small b here, means that the level of B are set at positive while the level of A is set at negative. AB means that both A and B are set at positive level. In the factorial design experiment, we have what we call as main effect and interaction effect. So before we proceed, let's have a look at what's the meaning of effect. The effect of a factor is defined as a change in response produced by a change in the level of the factor. So the main effect means the average change of response when one factor is changed, either is A or B, while keeping other factors constant. The main effect of factor A is the difference between the average response at the high level of A and the average response at the low level of A, and it can be calculated as follows. The main effect of B can be calculated as follows. The interaction effect, on the other way, is the average change of a response when several factors are changed simultaneously. So when those factors are changed simultaneously and the factors strengthen each other, we call the effect as synergistic effect. However, if those factors weaken each other, we call the effect as antagonistic effect. The interaction effects shows the difference in the diagonal average as shown in the figure here, and it can be calculated as follows. So what's unique in the factorial design is the ability to measure the interaction effects. Other design cannot measure the interaction effect. In general, the interaction effect should not be ignored as they may exhibit large value. So that's all for today. See you in the next video.